To initialize this assigning probability, we'll just set uniformly. So therefore, our ij will be just equal to 1 over the number of labels of capsule I. And for each of the child capsule, they have the input is basically, as I mentioned, the activations, A1 up to AN, and also the post matrices M1 up to Mn. And then the first thing, we'll compute the pose that we are going to transform the perspective from the child capsule to the parent capsule by multiplying Mi by Wij to get like Vij. And then like we are going to update the assigning probability by scaling it with the incoming activation. As you can see initially, because it's all uniform, so it's here I draw it like with the same thickness, but assume like here like activation here is larger, basic AV is largest, and then A1 is larger than A2. So then these assign probabilities for these branches from this child capsule number 3 will be larger than let's say this child capsule number 2. Then we're going to estimate the mean and variances. It's just the weighted sum using this assigning probability, as you remember earlier. The mean is just the weighted sum of the Vij there, and the variance is again like estimated the instantaneous variance using Vij, and also it weighted by this Rij there. Then we are going to compute the cos, and remember the cos is actually given by this equation here. Actually, I didn't emphasize earlier on that I find it kind of fascinating because the cos at the beginning, it depends on this Vij, right? You can expect because that's estimate the the probability of Vij given the current mean and variance estimate, right? But it turns out that if you look at the expression, it doesn't depend on Vij. It's kind of interesting that I like to point out. Then afterward, of course, we can just sum over all the cos and set at the bias with B1 and then multiply by lambda and apply sigmoid for that to compute all the activation at the output. Then in the E step, now we need to re-estimate the assigning probability. So basically for each of the Vij and with the current estimated mean and variances, we'll just compute what's the probability to have Vij happen, and then we'll just compute the product of all this probability over all the poses. The assigning probability Rij actually will be scaled not just by the incoming activation, but also the outgoing estimated activation. So it will be scaled by Aj, and then of course we need to normalize it, have this over this sum of Aj Pij here. And then of course we'll just repeat the M step again to re-estimate all the mean and variances, and also compute the cos and compute the activation output. And then these steps is basically repeat like a couple of times, like 3-4 iterations in practice.